The EChem startup system can be used for plotting the IV curve of a solar cell. If you click on Applications and this application note, you'll find a procedure for plotting the IV curve of a solar cell in EChem software. You should start by preparing the solar cell. You need to scratch off the protective film from the contacts. You can do this with either a sharp knife or a soldering iron. You can then connect the potentiostat to the solar cell with the electrode cable. You can identify the positive contact by these patterns, so you should connect the working electrode, the green clip, on the positive side, and the yellow and red reference on auxiliary on the negative side. You can then turn on the potentiostat and open EChem software. In the Techniques menu, click on Linear Sweep, and you want to change the potential range to 10 volts and click OK. You can then go to the potentiostat window. You can now turn on your light source to illuminate the solar cell. You want to then change the cell to real, and you might see a change in the recorded current. You need to select a current range appropriate, so if you have 3 milliamps, you should change this to a range just above that, so say 5 milliamps. If you're getting a negative value, you should click or unclick the invert button so that it becomes positive. And you now want to apply a 10 hertz filter to get a cleaner signal. This recorded current is the short circuit current for your solar cell under these lighting conditions. You now want to slowly apply a voltage by sliding potential slider, and you can see the current is decreasing. You want to gradually increase the voltage until you get to about zero current. When you're about zero current, this value is the open circuit potential, and you should make a note of this. You now need to click OK, not cancel, because you want to keep the low pass filter and the range, and click Technique Linear Sweep. My open circuit potential was 3.160, so I want the current range to be just above that, 5 volts. And then here I'm going to enter my open circuit potential, so 3160 millivolts. You want to choose a suitable range. If you click on View, you can see that this is going to take 12 seconds. Let's change this to 200 millivolts per second. So now the scan is going to take about 16 seconds. You click OK and OK. Before you click Start, you can go to Display and Overlay All. In the overlay display settings, you can set the overlay display to say light blue. And now you can click Start. And you should get a scan from about zero current. And as the voltage is decreasing, the current flowing is increasing. When it's finished, you can give it a name, and you can do another scan. And see how it compares to the first scan. You can then change the lighting conditions slightly and click Start again. You can see that the open circuit potential was changed slightly under the scan. Now looks a bit different. Under these new lighting conditions, you can see that the open circuit potential is here at 2.8 volts. So in Technique, you can change this to your new open circuit potential, click OK and run again. and you can continue doing scans under different lighting conditions. You can make a record of the lighting conditions using the notes. So in here, for example, you could call this medium light. There's a note of that here. This one was an earlier run, we can cut this one. Number 2, for example, this could be high lighting condition.